Now, just before I get started, so at this stage, everybody should have created their AWS, their personal AWS account. But what I'm noticing from interacting with some of you is you're having difficulty creating an account. Um, so what I can judge as to what's happening is when you try and create an account, at some stage in the registration process, you have the option of picking the free tier or the paid tier. And you should be able to pick the free tier option. But then when some people do that, it's not accepting that option or it's not giving them that option. And what I can work out is from what you're telling me is that the credit card and or the phone number, probably mainly though uh, the credit card number that you're providing it with is already in use. Now, I'm thinking what's actually happening is that you have already created. Now, of course, this only applies to people that have had difficulty or maybe haven't gotten around to creating it yet and will encounter this. I think what's happening there is um, you have already created an AWS account from way back in first year in the computer systems module. This is what I'm gathering now from just talking to some of the other lecturers. As far as I'm aware now, in the computer systems module, you were required to create an AWS account, which would have involved going through the same process that I was asking you to go through this last week, registering, providing a credit card, etc., etc. So if you are having problems, then you need to try and go back and see, can you log into that account that you created, whatever, 3 years ago now at this stage. And if you forgot the password, which you may well have, then you can just reset your password. That sort of typical scenario. So I just wanted to mention that at the outset, if some of you are still in that position, and get on to me over Slack if you're still having problems. Okay, uh, I'll pause just in case there's any query into as regards to what I've just said. No, okay. So the last day we started talking about the CDK framework, and I was about to give a demo on it. Now, of course, if you've already done these two labs, that's great, which means you're kind of ahead of me now, really, and that's all right. I'll catch up eventually. So I'm just going to go back to this set of slides and do the demo. Um, okay. So briefly, what this CDK framework allows us to do is to automate the provisioning of infrastructure on the AWS cloud uh, using code, but instead of writing declarative code, for example, JSON or YAML, we can we can express the infrastructure that we want to have provisioned using a kind of an imperative language or procedural language. And there are many options available to us. We are using TypeScript. So if I fast forward to here, maybe we said the last day that so we talk about a CDK application, and a CDK application is made up of stacks. Stacks are made up of constructs, and constructs uh, create resources. So resources there is the essentially the things, the pieces of infrastructure that you want to create on the cloud. Um, and we just talk about it. We just use the word application or app because whenever we're talking about programming, that's just a term that we use. But of course, in this case, our application doesn't have functionality. It just triggers the creation, the provisioning of our infrastructure. That's fine, and we have a visual kind of representation of the relationship between these different concepts. I did say the last day as well, is that in our case, except maybe until the very end of this module, our CDK apps will only consist of one stack. From a workflow perspective, this is what you go through. You first of all create a skeleton CDK app, telling it what language you want to use. And then really apart from that command, the only other two commands that you're going to be using is CDK deploy, which triggers the provisioning of your infrastructure, and CDK destroy, which triggers CDK deploy and CDK destroy. Destroy triggers the tearing down of your infrastructure. And the really nice thing about the CDK framework is even when you tear down the infrastructure and you realize, oops, I actually wanted to do some more investigation with this particular stack, then all you've got to do is just run your CDK deploy again, and it just builds it back up for you straight away. So going CDK deploy, destroy, deploy, destroy, deploy, destroy, that's not a problem. That's the beauty of using this CDK framework. And then I think I was about to do the demo. So we said this is the structure of the CDK application, and really the main part of it is in the lib folder. That's where you put your stack code. This file up here, this is kind of, we might call it the app implementation. Although it's just only probably about 2-3 lines of code, the majority of your effort will go into here. And the final point I made before I started doing my demo is that so we say an app is comprised of stacks, and a stack is comprised of constructs. Not a great name, but anyway, that's the name they use. And we said that there are three types of constructs: L1, L2, and L3. We will spend the most of our time creating L2 constructs. And an L2 construct, we said, was one L2 construct typically creates many resources, many pieces of infrastructure. Okay, so then demo time. So here is a CDK project that I've loaded into my VS Code, and it is a node project because it has a package.json. And if we quickly just glance into it, we can see, look here, I'm referring to my CDK framework, and I'm also, the CDK lib is kind of is the library that you use within your stack code, and as we'll see. The other ones are this one here. That's obviously TypeScript, but where is it? Oh, I'm not, sorry, there is another one that's important, but I actually don't need it here as it turns out. Okay, so if we look at this file, this is what I'm kind of loosely referring to as the application or the app implementation. I know now we had this the last day, but and there's really only 2 lines of code that you typically, and it doesn't seem to be tend to be any more than 2 lines of code in this file, unless you've got a multi-stack app. Line number 1, that creates an empty CDK app, and in this line, I'm essentially adding my stack to that app. Although we kind of do it the other way around, we we pass the app to the stack, but effectively it's adding the stack, my stack, to my app. And so we now want to look at the implementation of my stack, which is this file here. And if we go to the very top of it, it's a stack is implemented as a class, and lo and behold, it extends the stack class. So that tells me straight away that this is indeed a stack implementation. And according to our diagram there earlier on, a stack is comprised of constructs. Now, we just skip over some of this stuff. Here is a typical example of a construct. And in this case, I'm just going to collapse that. So here's a typical example of a construct. And it looks like, if we kind of zoom into it, it looks like the construct is concerned with creating an EC2 instance. And we know what an EC2 is in the AWS world. Another example of, so that is your classic example now of an L2 construct. This guy. Another example, if I scroll up and just ignore some of the stuff, here's another L2 construct that I'm creating. This construct, it looks like it's creating an EC2 security group, which we can relate to that. Now, if you what you'll notice is that the the parameters of the constructor for these constructs, the parameters are the exact same for every L2 construct. There are three parameters. The first parameter is referred to as the scope parameter, where you're indicating what is the scope of this construct that you're creating. And 99.9% of the time, the scope is going to be the stack that this code is contained in. So when I have this here, this is referring to the actual stack that's going to be created. Yeah, my stack. So, and that makes sense. The construct is part of the stack essentially. The second parameter is just an arbitrary identifier that you want to give to this construct. That's anything you want to be. It's a string. And the third argument then is essentially kind of an object, set of key value pairs. And if we look at the other L2 construct that we have, the first argument is referring to the scope that this construct applies to, which again is our stack. Second argument is the arbitrary identifier that we want to label this construct with. And the third argument is an object. So the only thing that's different from one L2 construct to another L2 construct is what is the structure of this object. And and that obviously depends on what is the actual construct that you're creating. In this case, it's an EC2 instance construct. In the case above, higher up in the code, it's a security group construct. Now, we can find out what are the various key value pairs in each of these constructs for the various types of resources that we want to create. But I'm not expecting you to necessarily delve into that. But if you did, if you were just curious, I wonder what are the different options available to me here when I want to essentially kind of configure an L2, sorry, when I want to configure an EC2 instance. Well, what you need to do is to dig out the TypeScript declaration file that accompanies this class implementation. Okay, this is obviously a class because like we're proceeding with the new operator, so we know that new means that this thing must be a class, TypeScript class. And those TypeScript declaration files, they come with the library that you've installed when you ran the npm install on this. And all you've got to do is simply mouse over it, click, select that, and now I'm thrown into another file. And if you look over at the on the right here, yeah, you can see that the file is a .d.ts file, TypeScript declaration file. And here is the declaration. Now, okay, we didn't have any classes up to now, but uh, you're very familiar with classes, and classes are something that you also put into a TypeScript declaration file. We were just putting interfaces, interface data types, aliases, all that kind of stuff. But it's also where you would place your class implementations. And if we look at the constructor for this guy, there's a couple of static stuff, but eventually there'll be a constructor somewhere. Where's my constructor? Oh yeah, there it is there, look. And as I was saying to you, the constructor takes three arguments. The scope argument, which was always this in our case, the ID argument, which is of type string, and the third argument for all of your L2 constructs is what we refer to as the props argument. That's the kind of the object structure, and that's going to vary from L2 construct to L2 construct. Now, this is we're looking at the EC2 instance L2 constructor. And so the shape of its props argument is unique to it. And here we're told that it's of type uh, instance, what is it? Instant props. So that's obviously, I wonder what that is. If I click on that, and voila, I have a interface data type declaration, uh, which is describing the shape of this object. And if you scan down through it, what you'll see is that, the majority of the properties in this object are optional. Remember our question mark symbol to indicate an optional property. And, you know, again, when you get into the CDK framework, and I don't really expect you to have that much time to start poking around these TypeScript declaration files, but just in case you were interested, this is where you find all of the information. Apart from Googling and apart from asking ChatGPT, this is where you find the definitive kind of information on the various data types and classes, etc., that are provided by the CDK framework. So, if we go back to our code, which is here, so sorry, if I go back to here again, sorry. Where am I? Oh yeah. Um, what was I going to say? Oh yeah. So there's lots of properties within this interface data type, right? And pretty much all of them, in most cases, are optional. Some of them are mandatory, but most of them are optional, which means you can leave them out. And if you leave them out, then there is a default value assigned uh, to those properties. Okay, and usually the default, by its nature, tends to be the most common value that we want to set it to. So hence we can leave it out, and that's the beauty of it. Like you're being told, there's this, you've been told here, like what is the default value? And sometimes the default value is nothing, but in other cases it's an actual value that's assigned to it. So I'm just going to scan down through it. No, not availability. No. Some of them are Booleans. They get set to true or false. The false value being one of them. Just wanted to pick out something. Okay, so one of the properties here is VPC, and it's actually mandatory. It's not optional. And if we go back to our code, we are actually setting the VPC property to something. I'll explain in a minute what we're setting it to. And so on for the other ones. You could spend ages poking around these TypeScript declaration files. Um, so anyway, that's kind of what these L2 constructs are all about. Um, so okay, this L2 construct is going to eventually create an EC2 instance. And if we skip over some of this stuff here, I'm describing essentially the type of instance that I want. So I can just tell you, look, it's going to be what's called a T2 micro. You might remember T2 micro with, in my case, Linux installed on it. Where does it say Linux? Yeah, here I want the Linux operating system installed on it, and some other issues as well, some other settings as well. Uh, okay, sorry, just before, let me just deploy this while I'm rambling on. CDK, deploy, because it does take a little bit of time, depending on your network, of course. Yes to that. Now, when I hit yes here, the deployment process begins. What does that mean? What it means actually is that the CDK framework is going to create the CloudFormation template for my CDK app, and it's going to upload that template to the CloudFormation service, and then the CloudFormation service does its thing. It creates the various resources for me. And it's the CDK, sorry, the CloudFormation service kind of regularly updates the client. The client in this case is my CDK running locally here. It updates it in terms of its progress. So if I go yes, it's creating the CloudFormation template and chain set. And here now is where it's kind of up. CloudFormation is up, telling me, keeping me up to date as to the progress it's making in creating the various resources. So it's creating an EC2 instance, but it's creating some other stuff as well, some other resources as well. If you did want to see the CloudFormation that's generated, if you see this folder here, CDK out, and if you drill down into that, you will find the actual template in JSON form. Don't know why, maybe there may be a way of getting it to generate it in YAML form, but here's the CDK CloudFormation template in JSON form that my CDK framework generated for me. Again, I never look at that, and the whole point of using the CDK framework is that you don't need to go drilling down into them. Now, while it's deploying, I'll just let it work away, and we'll go back to our code and maybe just take it from the top down. All I'm doing here, and it's fairly obvious that the names are kind of useful. All I'm doing here is I'm just getting a reference to the default VPC that's created for you. Every time once you create an AWS account, as you know, the AWS will create a VPC for your account. And so I'm just getting a reference to that. If I wanted to, I could create my own VPC, and I would just use the relevant L2 construct to do that. So that's fine. That's all that's going on there. Uh, I want, when my EC2 instance is going to be booted up, I want a kind of a startup script to execute. And this is my startup script. You remember in AWS terminology, the startup script is referred to as user data. Don't know where they came up with that name, but so that's what I'm actually doing here. This is um, it's not an L2 construct as such really, but it's just anyway. What it's doing is it's creating a user data uh, resource, I guess I'll call it, for me. And here's the actual script of my user data. And if you looked at it, you can see what it's doing is it's installing the Apache Tomcat web server, and it's just creating a simple default page for the Apache web server, which is very similar to what you would do in the lab if you've already worked your way through the lab. So that's all that's going on here. Here I am creating a security group, as I mentioned a while ago. So this is, again is another example of an L2 construct. I'm passing it a reference to my default VPC. And here I'm just saying allow all allow all outbound traffic. Here uh, I am adding an inbound rule to my security group. I'm kind of assuming now people are familiar with security groups and inbound rules and outbound rules. Uh, so I'm adding an inbound rule, which is opening up port 80, and that's obviously because my EC2 instance is going to be running a web server on port 80, so I need to be able to access it. And I'm then attaching that security group to my EC2 instance. And this thing here really, this is not a construct of any nature. Or if you want to output something to the terminal, when you go CDK deploy, if you want to output something to the terminal, we don't use console log. We use this special, what is it? It's a method really, I'd say, uh, where you just specify the name of the thing that you want to output and a reference to it. So what I wanted to output is the domain name of the EC2 instance, uh, so that I can browse to it. Okay, I could output its IP address, its public IP address here, and use that instead, either or. So this CFN output, that's how we uh, get essentially kind of the equivalent of console log. So hopefully my stack is deployed. Yeah, so everything looked okay. And apart from this message, which you can turn off, I said I'd leave it on. I think all it's telling me is that there's a newer version of the CDK framework. I don't care about that. But if I scroll back, uh, this line here, okay, that was generated by the CFF output uh, instruction in my code. So this now is the domain name of my EC2 instance. And so if I browse to that, because I'm going to be using port 80, I should get the response that my Apache web server should return back to me its kind of home page. And sorry now if I'm boring you with this now, but I've specified here that this is the home page content of from my Apache web server. So hopefully that's going to work for me. Just grab this. As I said, if you walk your way through the lab, uh, this is all old hat to you, but and voila. Okay. Now, from a AWS point of view, though, let's see what's actually happening. So if I first of all go into the CloudFormation service, um, here is the stack that it has created for me, the CloudFormation stack. So if you like, there isn't a CDK part to this management console. There isn't a kind of a CDK area that you can go into and see what CDK apps you have deployed. You can only look at your applications from a stack perspective. So that looks as if it's been created properly for me. And because I know it's created an EC2 instance, if I go over to my EC2 console, probably should have shown you this before I deployed it, but you can ignore this EC2 instance here. That's something that I'm using for another module. It's in stocked state anyway. Here's the EC2 instance that was created. So that this is the instance that's running my Apache web server. It's in the running state. And if I go into it, and in particular, if I look at the security group, let's say, security. Here's my security group. And as expected, port 80 is open as my code kind of requested. So that all looks to be in order. If I want to make some changes to my stack, then and let's do something simple. Supposing I want to add another inbound rule to my security group, you just go into your code and let's enable this bit of code here. So I want to add port 22 to my security group. Yeah, and that's the only change I want to make to my stack. Now, all I need to do now is just run CDK deploy again. And the CDK framework does check to see if there are any security implications to the changes that you've made. Sometimes there aren't, but if there are, then it does ask you to confirm that you're happy with these security changes, which is obviously the case in this instance because I'm adding to my security group, so it couldn't be more obvious. Yes to that. Now, when I hit yes here, um, again, it's going to go through the same process of updating my CloudFormation template and sending that up to the CloudFormation service. And the CloudFormation service, as it always does, will do a diff between the new state of my stack, my desired state, if you like, and the current state of the stack, and then talk to the relevant services to make changes to their particular resources. So in this case, the only one, I guess, will be the EC2 service and telling it to change the security group. And so when this finishes, I can just go back to the management console and check that the security group has been amended. Okay, so a lot quicker this time because, you know, less less work involved in the deployment. Now, I'm not sure, does it create a new security group or does it amend the existing one? I don't think. I'll just try and do a refresh here. Uh, refresh just work. Oh yeah, that seemed to work okay. So here we can see the new inbound rule that has been added according to my request. So that's all in order. And in the same way, if I want to kind of remove, amending doesn't always have to be adding new parts to your stack. If I want to go back and undo that change, so if I take this out again, and deploy again, go back. And again, I don't know, does it create a new one or does it amend the existing one? What's happened here now? Let's see. I'm not sure where I am there now. Let's go. Let's take the long route. Select that and that and that. Just going to do a refresh here. Now we are working across the network, of course, so things don't happen instantaneously. That becomes an issue a little bit later on. You do have to allow for that. Oh yeah, so there's only the SSH inbound rule is now gone and the port 81 is still there. Okay, and so that was really one of the great benefits of, and it's really CloudFormation is doing the hard work there. It's not really the CDK framework that's giving us this nice, convenient way to change our stack structure. It's really CloudFormation is doing all of that work. Um, okay, as usual, I'll give you an opportunity to ask any questions if you have any questions for me so far. No, okay. Before I leave this one, so we have the kind of fundamentals of CDK. I guess that's the kind of objective of this demo. Um, right. There's a message on Slack. I don't know if it's from me or from somebody else. I'm not going to read that now, unfortunately. I'll go back to it later on. Sorry about that. If that person is online. Okay, so let's park that, although we are using the CDK framework right throughout this module. So the next topic is called serverless architecture. There'll probably be two labs, I think, in this section, or maybe even three. So you certainly don't need to go at this until next week. If and so let's introduce the topic with these slides here. So I guess the, the precursor to serverless, even though there wasn't a label on it as such. We might call the precursor to serverless as serverless centric, but like I say, serverless centric, that didn't really exist as a term. And anybody that has Googled anything about serverless will know that the very first thing you learn about this serverless idea is that it does not mean that there are no servers being used anymore. That just wouldn't make any sense. There has to be servers working at the back end. What serverless really means is that you, as a developer, don't concern yourself with provisioning servers and configuring them and patching them and checking that, if you need to have multiple instances of your server running, in other words, scaling, you don't have to worry about any of those issues. The cloud provider manages all of that for you. And I'm sure, as would have been said to you in last year's module, essentially you're relinquishing some control over the kind of stack. You're letting the cloud provider now take control of a certain part of your stack, the stack being from the hardware up to the operating system, any third-party dependencies, all of that now is being managed by the cloud provider. You no longer do it. And if you're happy with relinquishing that control, then serverless is definitely something you should consider as a as a platform for deploying your applications. Now, applications in the traditional sense of the word applications, applications as in functionality. You want to deploy some functionality onto the cloud, but you don't want to be bothered with creating the underlying infrastructure and operating system and all of that sort of OS level stuff. You want to uh, kind of almost ignore all of that. So serverless doesn't mean there are no servers. It just means you don't have to concern yourself as a developer with them. And so all of these kind of things here are no longer issues that you have to deal with. And I've kind of mentioned them, already. You can scan over those yourselves. So if you decide that you are going to adopt this serverless uh, kind of platform, then as I already said, there are no servers to provision. You don't actually, like we, in the example that we were just demonstrating there, we were provisioning our server essentially. Both the virtual machine had to be provisioned and the installation of the Apache web server. We had to do all of that essentially ourselves from a provisioning perspective. Yeah, but now potentially a lot of that is taken away from you. Scaling, you don't have to worry about. If our Apache web server, let's say it's hosting something more elaborate than just static websites, if it's hosting actual web applications, server-side rendering web applications, and there is a very high volume of traffic hitting that server, and our server is starting to suffer from a performance point of view under that volume. Then the answer obviously is you create a second instance of the server and stick a load balancer in front of it and let the load balancer um, balance the workload between the various copies of your server that's running. Again, that's scalability. But if you take the serverless approach, then those scaling issues are actually dealt with by the cloud provider themselves, and we'll see that a little bit later on. No upfront costs. You don't have to spend any money buying both VMs or whatever, or paying for VMs. Availability is taken care of for you. Uh, this idea of having multiple instances of your application, your functional application, having multiple instances of it running, let's say on different, maybe in different regions and in different AZ zones. These are all concerns that you would have if you were not taking the serverless approach. But with the serverless approach, again, the cloud provider provides certain guarantees in terms of the availability of your functional applications. Okay. This was a nice diagram I found somewhere. So, like over the decades, really, I suppose, this is how the world has changed from a developer's perspective. Once upon a time, developers bought their own hardware, installed the operating system on it, and installed whatever else on top of that. So they had to deal with everything from the hardware up. Then with virtualization, you were no longer concerned with kind of the hardware side of things. You've done a lot on virtualization, e.g. EC2. So I'm not going to go into the benefits of virtualization versus, you're dealing with the hardware side of things yourselves. Then the next iteration or layer of abstraction was containerization. I don't think you've done a lot on containerization, but it's a bit like many VMs, I suppose. I'm not going to do anything more elaborate than that. Where serverless comes in is we talk about the idea that as a developer, all you are concerned with is writing code, and everything below your code is managed for you by the platform. Yeah. So it's kind of a nice illustration of how things have evolved over the years. Now, in the AWS space, they certainly provide serverless services. And all I'm doing here is listing some of the AWS serverless services that are available to you, and they're target different parts of an application. So in terms of compute, um, compute related services, EC2 is a compute service, but it's not serverless. The dominant compute AWS service is Lambda, and we will spend quite a while looking at the Lambda service. And what you'll see is that we can actually just write a piece of code, give that to the Lambda service, tell it, of course, what underlying um, platform we want to run that code on, like we want to run it on a version of Node version 22, maybe specify the operating system if that's relevant, how much memory do we want, that kind of stuff. So the Lambda service is AWS's main serverless compute service. If you want to do data storage in a kind of serverless sense, then the one of the database services is called DynamoDB. DynamoDB is a non-relational database, but again, you don't have to worry about spinning up a database server. All of that is taken care of for you by the provider. There are relational database serverless services, bloody mouthful, but anyway, they're there as well. But we just won't look at them for no particular reason. We'll just focus on DynamoDB. Cognito is a service that kind of deals with user account management. Gateway, API Gateway is kind of a front for, you might remember in the web app dev module last year, where you created a RESTful web API, and you ran it locally, and some of you may have deployed your web API to a cloud provider, maybe Heroku or some of the other ones. Well, API Gateway is where we can deploy our RESTful web APIs to, and not worry about, again, the underlying platform. S3 you're familiar with, that's file storage, but it's technically serverless as well, even though it predates serverless. And there's some other ones as well. We will look at SQS and SNS at the back end of this module. Kinesis we won't look at. Aurora. Aurora. Uh, oh yeah, Aurora is actually a relational database serverless service. Step functions we won't look at, and so on. So there's lots of them there, and there are others. On the right, what I'm actually showing you is your kind of classic serverless web application. Um, so again, if we go back to that web app dev module that you covered in third year, where you developed a React app, if you remember, as your front end, and then a RESTful web API as your back end, and I think you use MongoDB as your database. So it's your three-tier application. Now, if we want to if we want to deploy that type of three-tier web application to the AWS platform, and we want to use a serverless architecture approach, then this is how it might look, right? We would use the DynamoDB service for our data storage, which it is quite similar to Mongo, but it's a database service anyway. So that's fine. We would use the Lambda service for the various endpoints in our RESTful web API. We would use API Gateway as a front kind of client-facing side to our RESTful web API. So, when there's a request to a particular endpoint in our web API, that request is first handled by API Gateway, and it will route the request to the appropriate Lambda. There'll be lots of Lambdas here implementing the actual functionality of our web API. And the gateway, its role is really to match the request to the appropriate Lambda and maybe do some other validation as well. Cognito over here will take care of essentially user registration, user login, and it works kind of with the API gateway. And over here on the left, that's where we actually would store our React app. Yeah. Um, so you can relate to the nature of the application, three-tier web application. This is how it might actually pan out in terms of deploying it to the AWS serverless option. We'll certainly do all of this stuff here. Uh, previous years I have done Cognito, some years I haven't. And only at the very, very end might we actually look at the deployment of the front end. So we're going to spend the next couple of lectures going through this AWS Lambda service, which is the AWS's main serverless compute service. And I think this is straight out of Wikipedia. Sorry about that. But so this Lambda service we're saying is event driven. So the way we trigger our code is via some event, and the event can be sourced from lots of places, as we'll see. So it's event driven. It's serverless. We've said that too many times. It's computing or compute kind of platform. Maybe I should have said that rather than computing platform. So it's not storage. It's not messaging. It's not any of those other parts of an application. It's really dealing with just the compute power that you require, provided by AWS. Okay. It's run its code. So the code that you write, you literally write functions. Okay. And you deploy individual functions, and each function is deployed to a Lambda resource. Yeah. And what the Lambda service will do is it will allocate RAM, it will allocate bandwidth, and it will allocate CPU credits, if you like, to your function to enable it to run. And then when does it run? Well, it runs whenever the particular event that is associated with that Lambda triggers the triggers the execution of it. And we'll see that in a while. So in a way, Sorry, no, let me just take a drink of water. Uh, this is another way of kind of describing what this Lambda service is about. It's custom code, and we know now it's actually just down to the level of a function. It's a function that runs in an ephemeral container. Like what actually happens behind the scenes is when the Lambda service wants to run your custom code, your function, what it does is it creates what's called a micro VM instance. Container or micro VM is the same. Terms are used kind of interchangeably. It creates a micro VM instance. That micro VM will contain the operating system and any third-party dependencies that your code needs. So it could be, some Node.js packages, the Node platform itself, some Node.js packages. That's what we would mean by dependencies. Then it loads your code into that micro VM, and then it executes your function. And then when the function is finished executing, it essentially throws away the micro VM, trashes it until the next event occurs, and it goes through that whole process again. If there are a number of events targeting the same function, then clearly it's not going to be so silly as to keep creating a micro VM for every single event. It actually holds on to the micro VM and reuses it essentially. So, it makes clever decisions in that sense. Ephemeral, really, as you know, all that means is that the creation and destroying of these micro VMs is something that happens, multiple times. It's not like spinning up an EC2 instance. When you spin up an EC2 instance, you hope that to keep it running for a long time. Whereas these micro VMs are created and destroyed uh, multiple times, um, depending on the amount of traffic hitting your targeting your function. Again, this is just kind of the acronym that we kind of use. FAS is function as a service. We've heard of all of the other ones. Like we initially began in this whole cloud computing era. Uh, the first iteration of it was infrastructure as a service. Then we got platform as a service. Then we had software as a service. Now we're at the kind of function as a service stage of cloud computing. This is a visual representation of what I've kind of mentioned already. So you've got some event source. This could be anything. This could be from your command line. This could be another Lambda. It could be maybe an S3 bucket. Um, there is some source that's generating an event, and that event needs to be processed by your Lambda function. So this is representing my function. We call it my Lambda function that I've written. That event is first of all handled though, or it's kind of caught by the Lambda service and processed by the Lambda service. And by process, we mean it works out which Lambda should I invoke, because it's the Lambda service that actually invokes your function and passes the event to it. And then the Lambda service has done its thing. What the Lambda function does is completely dependent on what you put in the code. It may, in the majority of cases, it will actually talk to some other resource. It may talk to a DynamoDB database. It may put a message on an SQS queue. It may invoke another Lambda. But this idea of an event source, the Lambda service, and the Lambda function, they're the main kind of concepts that we need to just be comfortable with when we talk about the Lambda service itself and using the Lambda service. So the event source, or it's also referred to as the trigger, as in it triggers the execution of our function. It could be anything. It could be the source could be a HTTP request. It could be a a change in a data store. Maybe this is a database here and a new record has been added to the database. And we want this Lambda function to execute as a result of that. Yeah. So in that case, the database is the source of the event. It generates the event, and we'll see later on how we can get a database to generate this event when a new record is added. Similarly, it could be when a record is deleted or updated. So in that case, it would be let's say it's DynamoDB generates the event. The Lambda service catches that event and determines what Lambda function should I execute. And there are other options as well. It could be an S3, might be the source. This is an S3 bucket. This is an S3 bucket here. A user has uploaded a file to the S3 bucket, and we want this Lambda function to now execute whenever a new file is uploaded to an S3 bucket. So this is the idea of the event source for your Lambda, and how you express the fact that this S3 bucket, the file upload should trigger your Lambda. You express all of that in your stack file, as we'll see. And there are some other examples as well. The Lambda function then, that's kind of this guy over here. That's what you actually write, and we'll do a lot of that. Can be written in any language. We're going to be doing TypeScript. The Lambda service doesn't know anything about the implementation of your function. It just sees this as being the destination or the thing that needs to be triggered to process the event. And when I say it sees this as the thing that needs to be triggered, what I mean by that is it needs to create, the Lambda service creates a micro VM, which I represent by my box. This is my micro VM instance. So the Lambda service takes care of creating the micro VM instance, loading that instance up with the platform that's required, like the operating system, third-party dependencies, loads the Lambda function into the micro VM, and then triggers the execution of that function. And that's it out of the picture. The Lambda service has done its job. Bit of repetition going on here maybe, but so the Lambda service, what does it do? There's auto scaling. Let's just go back to that actually. Let's supposing there's a very high volume of these events being created. What the Lambda service does not do is pass all of the events to the one Lambda, because obviously then this is going to start either its performance is going to go down or it will start throttling, as we say. In other words, it'll start rejecting events because it can't keep up with the rate at which they're occurring. In that case, what the Lambda service does is it actually creates multiple micro VMs and loads each micro VM, goes through the same process of configuring the micro VM, and it load balances the events across the set of micro VMs that it does. This is obviously scaling, is what's going on here, horizontal scaling. And the Lambda service just does all of that for you for free. You have a certain amount of control over it, but it does all the heavy lifting. So it performs auto scaling, it performs load balancing, the kind of interlinked really, load balances between the micro VMs that it has created. Again, now sorry for going back and forth, but eventually the rate of the events will slow down and it then just starts trashing. It starts getting rid of these kind of as the workload starts to go down. OS maintenance, it takes care of making sure that the most secure and up-to-date version of the underlying operating system is loaded into the micro VM, takes care of any security issues, utilization. A micro VM is going to need certain amount of RAM. It's going to need certain amount of CPU power, networking bandwidth. It takes care, the Lambda service takes care of um, providing those to each micro VM. Same kind of stuff. What am I saying over here? We're now at the stage where if a function is now the unit of deployment. Prior to serverless, we deployed our entire application as a unit. Now we're deploying a much more granular part of our application, a function. Obviously, the functions will implement quite a lot of functionality, but it's not an entire application anyway. So our function is our unit of deployment. And also the unit of scalability, as I've illustrated. You do have to be aware of the fact that it's lambdas are stateless. Again, if I go back to here, um, an event is sent to this micro VM and it's processed. Maybe later on, another event is sent to the same micro VM, but it has no memory of the previous event that it processed. Hence, it's stateless. So you've got to accept that reality. And you may need to take that into account when you're when you're actually implementing your Lambda function. Runs on demand. Yeah. So by run on demand, we mean the micro VM is actually created only when it's needed. If there are no events occurring for a particular Lambda, there isn't going to be any micro VM waiting for an event to happen. Unless you want it, and there are edge cases when you may actually want a micro VM to be sitting there idle in a way, but at least sitting there configured and ready to roll if you need it. You can configure that. And you only pay for the number of executions of your function, as opposed to with EC2, when you spin up an EC2 instance and deploy an application to it, even if there's no request targeting your application, you're still paying for that EC2 instance being up and running. With Lambda, that doesn't apply. And that's why I mentioned to some of you in the labs during the week or last week that's why we're not going to be incurring very little cost as we work our way through this module, because it's all going to be serverless based. There'll be about a cost of maybe 10 to 15 euro for the semester at most, I would imagine. So all we do is we write our lambdas. Now we do have to put some CDK code into the stack, of course. We have to do that as well. But in terms of functionality, we write our Lambda functions. And we are just choosing to, well, this is kind of generic, I suppose, really. So, okay, you're going to have some imports on the top. That's all right. The next thing you have is what we call your initialization code. So typically that would be where, you want to make a connection to a database, or you want to connect to some other service, just establish a kind of a client instance so that you can talk to some other service. Yeah. So that's what we call initialization code. Then the main part of your Lambda is what we call the handler. So the handler is the actual functionality. So when I say, an event is targeting a Lambda, the processing of that event is done inside the handler function. Presumably the handler function will be referring to whatever you've initialized up here. If you've made a database connection up here, inside here, you're going to be talking to the database, writing records, deleting, whatever. Now, of course, if the Lambda function is quite large, you might want to factor out parts of it into private functions, and that's fine. But these are considered part of the handler as such. So the main components are the handler, Uh, oh yeah, the handler is a function, and obviously it's an asynchronous function because we're communicating over a network. You know, the Lambda service. The Lambda service is what calls our function, but still the Lambda service is communicating over a network to our micro VM. And so the parameters that are passed to our function are what's called the context, oh sorry, two arguments, the event and the context. The event, obviously enough, is the actual event in JSON form. Um, and the context, we don't actually ever need to use the context at all. I think that gives you access to the micro VM if you needed it, but that never arises in our case. We're only ever interested in the actual the event, the detail, the detail inside of the event, the data inside of the event, and maybe metadata as well. So, you know, in the case of where the source of the event was the file being uploaded to an S3 bucket, then the data might be the actual name of the file and the name of the bucket, for example. It's obvious enough, I guess. That's the event object, the context, as I've mentioned, and the initialization code I've mentioned as well. A bad implementation would be to put the initialization code into the handler. You can do that, okay, but there are it's a bad practice, number one, and there could be performance implications to doing that, as I'll explain later on. So don't do it, in other words. What's going on here? Oh yeah, so
Nirma, can I ask a question?
sure, yeah.
So in the previous thing with the event, does that also contain like the credentials and stuff for your AWS account so you can
No,
communicate with other microservices?
no, no, it wouldn't unless you unless the source of the event was programmed to put them in there. No, it wouldn't.
Okay, thank you.
Yeah. And I wonder why you're asking that now. Is it because is there a reason why you think it might or it could have?
Well, I assume that like a lot of microservices require authentication to even use some of the times, and sometimes you might want to trigger them with the Lambda functions. So I'm just wondering how that kind of gets done.
Yeah, interesting the way you use microservice there. These things are kind of slightly you could regard them as microservices. They're actually kind of part of a microservice, but if I was to go back to here, um, uh, the the credentials would be coming from Cognito, so the user kind of logs in some way, gets credentials, gets a um, actually, as I think about it now, maybe I gave you the wrong answer. So they log in. What Cognito does is it generates a token. That token is, yeah, that token then is included with the requests. So you remember, this is my web API here, Maria. Okay. The token is included with the request to this service here, API Gateway. API Gateway is responsible for carrying out authentication. So it looks at the token and it talks to Cognito and asks it, is this a valid token? Did you generate this token? Is it valid? And it'll say yay or nay. And if it's yay, then it forwards the request on to the particular Lambda. Now, you can, trying to think off the top of my head now, you can tell it to include the token in the, and so it's the event, in this case, to use the language, the event is sent down towards the Lambda. That event will contain the data. Let's suppose it was a post request. So the data in the post request would be in the body of the event, and that would be sent down to the Lambda, obviously, because it needs that. but you can as well get it to include the token in the event, but that's kind of a configurable thing. It's not automatic. There doesn't have to be authentication between here and here. The authentication happens here. Um,
I was more curious about the aspect with the Lambda to database because the database requires authentication itself.
yeah.
Because
Uh,
I assume hard coding the credentials in the function wouldn't be the best approach, right?
yeah. The database side, I think I've kind of conveniently bypassed that. Um, mm, yeah, I'm not gonna give a definitive answer. For sure, we will do a lot of this stuff, and there won't be any credentials used between these two. But I'd have to think about it now as to how AWS ensures that uh, the right lambdas. Well, the lambda when you in the CDK stack, you will specify the essentially kind of the IAM policy associated with this lambda. Okay, it's coming back to me now. uh, you will specify the IAM policy associated with this lambda, and that policy will control whether the lambda can talk to the database or not. So it's really IAM that's taking care of all of that. That's the whole point of IAM, if you remember. Yeah?
Yeah, that makes
Yeah.
sense.
So we will see when we look at a Lambda from the management console, when we drill down into it, we'll see that in the case of where it's talking to a database, to a particular DynamoDB database, we'll see that it has an IAM policy that permits that. Okay, I got there. Good question. Um, what's this about? Oh yeah. So uh, when you let's see. No, I'm just going to go into the demo. Actually, I skipped that slide for now because sometimes it's only when you see things working that it can make a little bit more sense. Anyway, hopefully, let's. So back to my slides. What do I want to do here? My objective is to use the CDK framework to provision a Hello World TypeScript stroke Node.js Lambda function. And I want to invoke that function. I'm going to invoke it just from using the AWS CLI from the command line. So the AWS CLI is going to be the event source. And also in my Lambda, it's going to be written in TypeScript. I'm going to have console log statements. And so the question is, where can we see these console log statements? Where are they outputted to? Because, our Lambda function is running up in the cloud. So where does it actually send these to? That's the objective here. So here's my CDK app, exact same structure as before. In the bin folder, same lines of code, create your empty app, create your stack, and there's nothing of interest. Look at the stack file. Uh, Before I do that, actually, sorry, that's not the stack file. This is the actual Lambda function implementation. And here's my handler. Its type is, it has a type, just like because it's a TypeScript function. And the type I'm importing from the AWS CDK library itself. We could look at it if we want to, but we don't really need to. It's an asynchronous function, two arguments. You can see the second one actually isn't being used. The first one is the event. And because it's an asynchronous function, I do need to wrap everything in a try catch block. I'm doing a console log, that's okay. And I'm not really processing, I'm not really processing the event at all. I'm not doing anything with it. I'm just responding with a status 200, and I'm sending back message, this message back to the invoker, which in my case will be the CLI. Okay, so it's your classic kind of hello world. It does have a console log statement. So in a way, the the body of my Lambda is just this single statement. Okay, and the return then is the response, the result of the processing that's been done here. But of course, it hasn't done anything. The catch block, obviously, if something could go wrong inside. Sorry, no, something could go wrong inside in the body of my function. It tries to talk to another service, doesn't have permissions to do that, or whatever. An exception is going to be thrown, and then the catch block deals with that exception, but it's not really what's it doing. It's sending back a status 500, which makes sense. Response back to the invoker. So that's my Lambda function. There's no initialization code. If there were, it would be up here. Is where I put my initialization code. From the stack point of view then, so I want to well, let's look at the stack. This is how we ask the Lambda service to provision our Lambda function for us. Okay, so we're creating an instance of, what's nice is that we can create an instance of a Node.js function Lambda. Now, implicitly, that obviously means that my micro VM that will be created at runtime will have the Node platform installed and any dependencies that it has. Again, this is an example of an L2 construct. And as before, the first parameter is the scope, which again is the scope is always the stack that this code is contained in. Second parameter is the custom identifier for this L2 resource. And the third parameter then is an object. And as I said to you before, the structure of this object depends on the nature of the L2 construct. And again, we could look at we could get some idea if we mouse over this and go into it. We could poke around and find out eventually, I'm not going to do it now, we could eventually find what are the different key value pair options that I have here. But if we just scan down through them, architecture, that's actually not mandatory in this case, but there's no reason why I need an ARM64 architecture running this code. No need at all. So I could really have left that out, and I don't know what it picks as the default architecture. The runtime, I'm specifically looking for Node version 22 as my runtime version of Node that I want. There's lots of options available to me. Like if I get rid of, as we're typing this code, when we go dot, we get all the options that are available to us. Not just Node, obviously, so it's not as clever as I would have hoped it to be. It's because it's giving me Java runtime options as well. But once we start typing Node, it narrows it down. And these are the different versions of Node that it supports. So it doesn't support anything older than Node version 18. So I just arbitrarily picked Node version 20. Again, all of this all of the kind of hinting there that was being provided to me was coming from another TypeScript declaration file that's sitting behind the scenes, and we could have a look at them if we wanted to by going through the same kind of process of mouse over the thing, click on it, and then that'll bring up the VS Code will bring up the TypeScript declaration file. But again, I don't think you really need to get into that. The entry point, the entry point is where is the actual Lambda implementation for this Lambda resource. We'll kind of make a distinction between the Lambda resource and the Lambda function. The Lambda function is the thing that we write. Lambda resource is the thing that is provisioned by AWS. So where is the code? And I'm just pointing it, essentially, I'm pointing it at this file up here. Underscore dir name is some global variable that's available to us within the CDK framework environment. My estimate as to the timeout is, well, if my Lambda function doesn't complete its execution within the timeout period, then I don't want, the Lambda to be running forever, obviously, because eventually that will cost money. So we set a time limit on terms of its timeout. And so if it's still executing after this timeout, then the Lambda function is going to be interrupted by the Lambda service, and the micro VM will be thrashed, and the Lambda service then will return an appropriate response back to the source, the event source. The memory size is how much RAM do we want to be provisioned for this Lambda function at runtime. Now, that if I go back to my slides, I kind of skipped over this slide here, which is really on about how do you tell the Lambda service how much kind of compute power it needs to allocate to my Lambda function. So I'll come back to it. But the way you tell it is not, you don't tell it how much compute power it needs. You tell it how much RAM does your function need. And it then works out how much compute power based on that. That's roughly how it works. Okay. So you do need to specify how much RAM space you want to have allocated. And again, there is a default. So I'm taking 128 megs, which I definitely don't need. But so that's it. That's all that's in my stack, right? I'm just provisioning one thing, a Lambda resource. All I'm doing down here actually is I'm just outputting the name that the Lambda service will give to this resource. It's just a kind of a randomly generated name. The name is comprised of the stack name, the function name, and then just a hash value, as we'll see. So if I deploy this, where am I on time? CDK deploy. Should be a lot quicker now because there's very little to deploy. And while it's working its way, well, let's just wait for it. Run out of patience. I'm going to go up here. And if we go again, just take it from the top down. If we go to CloudFormation, here is the stack, simple app stack. Where did that come from? If I go back to here, I told it I want to call my stack that, simple app stack. And given that you've got some familiarity with the CloudFormation service, you could, go into it and look over here to see what resources were provisioned, and you'll see that should have probably looked at it beforehand, but uh, this one here really obviously, but not obviously, but this is our Lambda function. But rather than looking at drilling down to that, which you can, we know, right, that there is a Lambda resource created. And so if we go over to that service, because it's just another service, so this is our first time probably looking at this service. Uh, and the service provisions Lambda resources. If I wanted to see all of the Lambda resources, click on Lambda here, and here are all the Lambda resources that I have created in my AWS account, and there's only one at the moment. And so this is the Lambda resource that was created as a result of the code that we were looking at in the CDK stack. And, the actual code associated with it is, if we drill down here, that's not the code we saw, but what is that code? This code here that we're looking at is the JavaScript equivalent, the JavaScript that was created by the CDK framework of my TypeScript implementation. But again, we don't really need to look at that, all right? But that's the code that's actually loaded into the micro VM. Because as we know, TypeScript is not a runtime code. TypeScript is a compile time code. The runtime code is JavaScript, and this is the actual JavaScript code, which, as I say, you would never really need to look at. That kind of defeats the whole point of implementing our Lambda function in TypeScript if we have to go looking at the actual JavaScript that's generated. But in terms of triggering my Lambda function, you can trigger any Lambda function from the command line using the AWS CLI tool. And so the way you do that is with this command. So it's not the CDK now, it's the AWS tool that we're using, AWS Lambda, and you've used the AWS tool before. So I'm telling it, look, it's the Lambda service that I'm sending my AWS request to. And within the Lambda service, I want to invoke a function. I'm going to specify the function name, and the function name, I could get it from the AWS Lambda console, but if we look at my code, am I looking at the right code? Oh yeah, I decided to output the function name from here. So if I scroll back up, here is the function name. And really, if I go back to the management console, it's essentially this name here, right? I think they're one and the same thing. So back to my command. So I need to change this bit here. I know there's just things popping up in front of me. Okay. There is the response.json thing at the end. you have to specify where you want the response from the Lambda to be put. It won't, don't think you have the option of outputting the response back to the terminal. So we want the response from the Lambda service to be stored in a file called response.json, which will be created locally. And the response should be this message here. So let's see. Don't worry about this. This is just coming from my terminal implementation that I have, so you won't be getting this prompt. So I'll just say no to that. So it looks good. I'm getting a status 200, and over here is the response.json. If I go into it, that indeed looks like the message that my Lambda returned. Yeah. And so that all looks good. And now in order to just down here, in order to quit out of that, just type Q. I don't know why it holds there, but it does anyway. So that's great. Now the only thing that's left though is the Lambda function. In its body, it executed a console log statement. And so where does that console log statement go? And the answer is it actually sends the log message to the CloudWatch service, which again is a service that you would have been familiar with from last year. So just about have enough time now. If I now go over to the CloudWatch service, now the way CloudWatch works with the Lambda service is CloudWatch creates a log group for each Lambda that you have. And for each invocation of your Lambda function, it creates a log stream within that group. You might remember from last year, that's the way CloudWatch, there's a part of CloudWatch called CloudWatch logs, which as you can see over here, right? And as I just said, logs are made up of log groups, and so in relation to the Lambda service, there's a log group for every Lambda function that or every Lambda resource that you have deployed in your account. And so if I click on log groups here, surprise, surprise, there's only one log group, and that's the log group for my Lambda resource. And again, the log group name is kind of taken from, the function name itself. If I go into that log group to see the log streams, now I've only executed my function once, so there should only be one log stream, and here it is down here. And if I go into that, this is what a log stream looks like for a Lambda function. And if we just break it down, so there are different parts to it, right? The first part here is what we refer to as the init part of the log stream. The init part, now, if we expand it, there's nothing in there. But the init part relates to the execution of the initialization code of your Lambda function. Remember, I talked about the initialization code and the handler, the two different parts of your Lambda function. Well, and so it makes sense that the initialization code is the first part of my log stream because that runs first. Okay. After that, then we have, I'll just collapse that again. Start here refers to the start of the actual handler. And anything after start and up to up to end, or in other words, everything between start and end is the body, is the handler function itself. So for every console log statement that you have in your handler function, there'll be a separate entry for it in your log stream. We have only one console log statement. That's why there's only one entry here between start and end. And if I expand this one, uh, here we go. The actual log message was I was invoked. And if I look at the console log statement in my Lambda function, that's what we wanted to log out. I was invoked. Okay. Now there is something I just wanted to play with for a second, and that is what I'm going to do is try to run. I'm going to trigger my Lambda function, let's say 3 or 4 times in quick succession, and look at the log stream as a result. So follow that. I hate the way it does that. Q, do it again. Q. This may not work out now, but we'll try it anyway. No. Q. And I'll do one more for good measure. Now, something as well as, what you will be doing a lot is looking at these log streams, mainly, when you're trying to debug a function. But let's just see anyway what happens. So I ran what I'm trying to do here is I want to try and create a situation where the same micro VM is being used to process a number of requests. But because everything is happening over the network, it may not actually work out for me, but we'll see how we get on. So again, if I still have one log group, and if I do a refresh of this, what I don't want now is an individual log stream for every one. Always, I should say that sometimes the log streams are slow to appear. So I don't know now if this is the most up-to-date one or not. Oh, it is. Okay, this looks good. So what's happened here now is also sometimes the log streams sometimes the log streams are not in the right order. We've no real control over that. But what you can see here is that, start means it's executing the handler. And I've got a start here. And I've got another start here. And I've got another start here. And these are all in the same log stream, which means in our case, they're actually coming from the same micro VM. It's not creating a separate micro VM. If it created a separate micro VM for processing each one of my requests, then I would have a separate stream for each of those micro VMs. Okay, this stream is linked to a micro VM. But that didn't happen in our case, and that makes sense because it already had the micro VM powered up, so to speak, ready to receive the request. So there was no point in trashing the micro VM and creating a new one when it received the second and third and fourth events in quick succession. Now, strictly speaking, we should have an init block as well. Is there an init block there? We just look down through it. Oh yeah, sorry, it's up here. Look. Okay, yeah. So this is a good example actually. Init block means it's running my initialization code, and then after that, it's running the handler multiple times. Um, I'm thinking now you're not going to find two instances of the init block within the stream. Let's just do a search, Control F. It's made a liar of me. There are two of them actually. It's not playing ball. Is that the same one though? Oh no, there is really only one. So there's an init block, which means it's run by initialization code, and then it's running the handler each time for each invocation. It's not rerunning the initialization code before each time it runs the handler. And this is a point that I made to you, and I will make again later on, because that's kind of important in terms of how things actually work behind the scenes. Okay, I'm kind of out of time really, but the only thing that we would need to look at as well is if we go into the Lambda function, we'll do it next week. Where is it gone? Sorry. And, if we look at the sort of the configuration of our Lambda resource, uh, there are some kind of useful things to be aware of there as well. But I'm not going to start rushing into that now. Okay, I'm going to stop at this stage. Again, I'll just give an opportunity for any questions in case there are any. No. So in terms of the labs, which is really for next week, but we just briefly look at the lab. In fact, we haven't gotten as far as I haven't even gotten as far as Lambda functions. You could just do the first two parts. You can go into this part as well. It's very prescriptive, but we haven't covered Lambda functions. So maybe this lab is going to span over next week and the following week as well. Right, I'm going to stop talking and I will touch base with you again next week. Thanks, bye-bye.
Actually, is there somewhere we're meant to submit the labs, the TypeScript lab we did?
Yeah, do you have, are you registered on Moodle? Can you see the
No,
module?
no.
No? Okay, if you just send me a Slack message, I'll enroll you. Now, the deadline is tomorrow. If you don't happen to get it, well, I mean, if you're enrolled, then presumably you've been working on the lab up to now, so you've done the actual work. You have the GitHub
Yeah,
repo.
done the yeah, I have
Yeah,
the good.
yeah, that's grand. So, all you need to upload to Moodle is if I go to it, assignments. When you click on that link there, you just upload the text file, which just contains the URL of your GitHub repo. But of course, if you can't see the module, then, and the same applies to anybody else, send me a message on Slack and I'll enroll you. And if you're not enrolled in time for tomorrow's deadline, you still have the work done. I can see on GitHub the timestamps on your Git commit. So even if you can't upload the text file until, let's say, next Monday, that will still be okay, provided I'm happy that you did the work, completed the work by this Friday. Anyway, so send me a Slack message, and the same applies to anybody else who cannot see my module, and I will enroll you. Okay.
Thanks.
Thanks a lot. Bye bye now.
Thank you.